All right, I think we're live. Hey, Liz.
Hey, how's it going, Graham?
Hi. Hey, everybody. I'm Graham Zimmerman. I am on the Protect Our Winters Climb team, and I am here right now with Liz Burakowski, who's a climate scientist on the POW Science Alliance. Hey, Liz.
Hey, how's it going?
I'm great. I'm at home and psyched to be talking about climate.
Yeah,
Um,
amazing.
so what we're gonna do here is we're gonna jump into a video right now, and it's about 18 minutes. It's a TED Talk that Liz did in September of 2019, so not too terribly long ago. And we're gonna dive into that, listen to Liz talk about climate, talk about the work that she's doing, and then we've collected a bunch of questions that you guys asked via Instagram over the last week or so, and we're gonna jump into a Q&A session with Liz for I guess like 15 or 20 minutes, and then we've got a raffle at the very end. So make sure and stick around. Liz, are you ready to jump into watching yourself talk about climate?
Let's do this. Sounds good.
Awesome.
One of my earliest memories of snow was captured by my parents here in Wisconsin. And this is my fraternal twin sister and I. And I'd like you to guess, who do you think is who? Raise your hand if you think I'm in the pink. If you think I'm in the blue. Yeah, all right. My dimples give me away. It's not hard to tell. And I still make this same face on a snowy winter morning when I pull back the curtains. And my son also has a similar reaction to snow, dimples included. And it wasn't long after this photo was taken that my dad's job moved us east to New Hampshire. And I remember discussing on the 20-plus hour ride in this car with my sisters just how much more snow New Hampshire had than Wisconsin. This was a rumor that was substantiated by my cousins who already lived here. And little did I know that this trip, this journey, would set me on a course to become a climate scientist still fascinated by snow. When we got here, one of the first things my parents did was go to a local ski swap and pick us up each a pair of beat-up atomic skis. Their friends had been living in Vermont for a number of years, and so they took us to their local ski hill, Suicide Six. And Suicide Six has its place in U.S. ski history. This is the longest-running lift-served mountain in the United States. In the 1930s, they installed a hodgy-podgy Ford engine rope tow that was designed on a prototype that had been built in Quebec. And I remember riding up the rope tow here. It's right that little J bar in the corner and lookers left with my sisters. And by the end of the day, we had mastered the pizza. I also remember my parents standing at the bottom of the hill, arms outstretched like goalies, ready to intercept us should we not be able to stop or turn. And you can imagine how this would have gone. 3 of us, 2 of them. Right? Arms stretched out. My dad saying, "You get Jesse, I got Lizzie. Katie, turn right, turn right." It was the best. And by the end of that season, we had mastered the face. That's that gigantic open trail that's right in the center. It was the steepest, mogulliest trail that we had ever seen. Now, Suicide Six remains open to this day, but many resorts have not been so lucky. In fact, some 600-plus ski resorts have closed since the 1950s. Some of this is due to the boom-bust and the popularity of skiing. Some of this is due to the fact that a lot of the smaller resorts were the ones that closed. These were small mom-and-pop operations with no more than a single rope tow. And they simply couldn't compete with the bigger operations that had invested in snowmaking and had more terrain offerings. But dismal winters also play a strong role. It plays a role through what's known as backyard syndrome. This was actually a phenomenon studied at the University of New Hampshire by Dr. Larry Hamilton, who noticed that skiers respond not just to how much snow is at the mountain, but also how much is in their backyard. And this makes sense. If it's a really big snowstorm, you're like, yeah, grab those skis out of the garage, head up to the mountains. If it's a rainy, warm February day, you're probably more likely to stay home. And when we think about this, it's not surprising that we see these types of impacts. We also need to consider the fact that in New Hampshire, things have been changing quite a bit. It was my love of skiing that drew me to snow science. I'd actually been working at the Seacoast Science Center as a seasonal naturalist. I called myself a tide pool tour guide. And when I saw this seminar flyer come through, and it was for a speaker coming to talk about climate change in the Northeast. I didn't make it to the seminar, but I tracked down the speaker's information. Dr. Cameron Wake, also at the University of New Hampshire. I'm sure all of you know him. Yep. And so he sent me his group's 2004 report, Climate Indicators in the Northeast, Past, Present, and Future. And one sentence really stuck out at me. Specifically, it said that winter was the fastest warming season in the US, or in the Northeast US. And this struck me. I mean, I was a skier and rider. I'd been skiing and riding for about 15 years at that point. I recognized it. I remembered recent years when my older sister and I would put on shorts and a t-shirt and go running at the high school track instead of putting on our snow pants and parkas and going skiing. So I very quickly applied to and was accepted to graduate studies at the University of New Hampshire. And my master's thesis, I decided to collect the highest quality temperature, snowfall, and snow depth records that I could find for the northeastern US. And the results were alarming. Our winter temperatures had warmed over 3 degrees Fahrenheit since the 1960s. We had also seen that some of the snowfall trends were a little mixed, and this made sense. A warmer atmosphere can actually hold more moisture. As long as the temperatures remain below freezing, you will still get snow. Keeping the snow on the ground, however, is challenging. And those warming trends had reduced the length of our snow season by 1 to 2 weeks. And this is one of those things that can be hard to accept. When we surveyed people in the Northeastern United States, we surveyed 1,000 people by telephone, and we asked them, are winters warmer today than they were 30 to 40 years ago? Less than half of the respondents responded correctly, yes, they are warmer. Climate change can be hard to accept. It can be hard to recognize. And this reminds me of my son. He's 4 years old, and he had asked me what my job is. I said, well, I'm a climate scientist. He looked at me quizzingly, like, so you're going all the way to the top, Mama? Thought I was climbing. He's so cute. And it makes sense. I mean, like a 4-year-old doesn't know what climate is. I don't expect him to. But he does understand weather. And he also has expectations of what weather should be like in the Northeast at winter. I remember on December 22nd of last year, on December 22nd of last year, we had no snow in the Seacoast. And he noticed this. He said, but Mama, it's Christmas. There's supposed to be snow. Maybe it'll snow tomorrow. And it didn't. It didn't snow tomorrow. It didn't snow the next day. It didn't snow on Christmas. And in fact, the next snow we got was after the entire holiday week. It was January 3rd. And the 2 inches that we got all melted within a day. Our next storm didn't come until the end of January. And the little snow cover we got then also disappeared in 4 days. That was after a big rainstorm. And it's one of those things where the trends have just continued. We have seen winter warming show up as a hotspot for the Northeast US. Compared to the rest of the US, our winters are one of the fastest warming in the whole region. And this can be troublesome. I mean, it can be one of those things where you have to wonder, what are we doing about this? I find myself thinking about other impacts that are happening in our ecosystems. It's not just a shorter snow season. We're also seeing earlier melt in our rivers and streams. We're also seeing more of our winter precipitation fall into rain instead of snow. Another major winter indicator is when our lakes are icing out. We also see sites like this. This is my field site, one of them in Durham, New Hampshire, and it looks like the end of the melt season, right? And what you can't tell by looking at this photo is that I'm wearing shorts and a t-shirt. This was one of the hottest days ever recorded in Boston history. It was 72 degrees. The low that night was 66 degrees. That's like sleep with your windows open type of weather. I had to wonder at the end of this day, is this the end of my snow season? Are we going to get more snow in March? It wasn't clear. This was also a year when ice out was occurring earlier. There we go. This is my mom. It's 1967. She's holding her a rather large pickerel. And my dad had taken her on her first ice fishing trip, probably her last as well, judging by her face. But this isn't Winnipesaukee. This isn't New Hampshire. This is New Jersey. This is Lake Hopatcong, right outside of Hackensack. And Lake Hopatcong was originally 2 ponds when the Lenni-Lenape first settled the region 12,000 years ago. And when colonizers came in, about 1750, they put in a dam, it became a single pond. It has since become a very popular ice fishing location, especially in the 1960s. And when my mom was growing up, the average winter temperature there was below freezing. Today, just 1 generation later, it's now above freezing. It's 34 degrees Fahrenheit. Ice fishing is still very popular on this pond, but lake ice is less reliable. We're also seeing fishing derbies canceled. And this concerns me on multiple levels. Are we losing a way of life in the Northeast? My life as a snow researcher can be rather invigorating. You probably recognize the smile. It's the same smile my parents captured on film when I was 4 years old. And I just love nothing more than spending my day outside measuring snow. But it can also take a psychological toll. This was a snowy day, but we also have our not-so-snowy days. We have our bare ground days, the brown days. And those days, we still go out and we still record the 0. And the zeros have started to pile up. But what really keeps me up at night are the climate model projections I work on. These sophisticated supercomputers can tell us something about our future. And what I see is not encouraging. If we don't act, if we continue on this path of emitting greenhouse gases, of letting them accumulate in the atmosphere, the seacoast of New Hampshire will have a winter season more like Virginia. A few weeks of snow at most. If we do act, there's the hope, is that we could preserve up to 2 months of winter into the future. This is by the end of the century. This is my son's lifetime. When I think about how else we can act, it becomes hard. I start worrying about not just the future and what it's going to look like, but how the future generations that follow us are going to react. I'm training students to measure snow at these sites. Are they still going to be able to do that when they're professors? I worry also about winter sports in the state. There's sports that I grew up enjoying skiing. My mom grew up enjoying ice fishing. And when I think about my son, he got to go skiing for the very first time this year. He had a blast. This was 2 days before this mountain closed for the year. It was in the springtime. And as soon as we got down from the mountain, he was like, when can we do that again? That was so much fun. And regrettably, I'm like, okay, next season, we'll get there, definitely. And it just had to make me wonder. I mean, that previous winter, we had tried to go locally. There's a little hill right here in the seacoast, Powder House Hill. Yeah? $5 for a ticket, 1 rope tow. It's 20 minutes from my house. And we had really hoped to spend some time there with him this winter, but the snow was so hard to come by that getting the days to line up and get out there were next to impossible. I also worry about New Hampshire. We attract 2.1 million skier visits every season. National Ski Areas Association defines one skier visit as one person visiting one ski resort for all or part of a day. So that's a lot for a small state. During our warmest, least snowy years, our skier visitation declines by 25%. That means that we're losing out on $40 million in economic activity. And if you live in the North Country, half of the economic spending is coming from the ski industry during that season. You feel the economic pinch of climate change. I worry also about what this means, not just for New Hampshire and our economy and our local communities, but for the communities that rely on snow, not just for currency, but for drinking water. The ones that rely on it for irrigation for their crops, the food they eat. The ones that rely on it to maintain their ecosystems and prevent devastating forest fires. When I think about our future, I wonder how people are going to act. And I wonder how other people react when they see a winter like 2018-19 in the seacoast, when they see a midwinter heat wave like we saw in 2017. Some people feel rejoice, right? Break from regularly scheduled winter conditions when it gets that hot. Other people feel disturbed, uncomfortable, like they don't even recognize their own home. That's how I felt. And it turns out there's actually a name for this. Oops, oh, missed that one. It turns out that there's a name for this, solastalgia. It combines the word solace, that comfort of home that you get, and nostalgia, that melancholy of homesickness. So it's a term coined by a philosopher, Glenn Albrecht, and he was doing this more in the context of people who are experiencing devastating forest fires, when they lose their home and their community, or people who have experienced mountaintop removal mining. The mountain they grew up with is no longer there. It can take a psychological toll on us to experience these changes in our home, in our own environment. Climate change can be abstract. It can be one of those things that it's full of statistics, or it's devastating events that you might not even see happening before your eyes, like melting ice sheets. We certainly experience those effects more locally. But when we see these changes in our own backyard, skiing in New Hampshire, loss of ice fishing in New Jersey, we can grasp it. It's right there in front of us. So I stand here not necessarily just as a concerned climate scientist, but as someone who loves snow, as someone who lives here in New Hampshire and loves New Hampshire, and someone who loves our planet and wants to see it preserved for our future generations and our current generation. So I ask you to please join me in this effort to preserve this vital part of our home. Thank you.
Take my hand and come with me into this crystal scenery and wait till I...
Hey everybody, you're back here with Graham and Liz. Hey Liz. I think there are a lot more folks here. So I'm Graham Zimmerman. I'm a professional climbing athlete and a member of the PAL Athlete Alliance. And this is Liz Burakowski, one of our Science Alliance team members. And Liz, can we just have you start by telling us a little bit about what you do?
I am a research assistant professor at the University of New Hampshire, and I study snow mostly in my own backyard. I do a lot of measurements locally, and I also run climate models. So I spend a lot of time typing away at a computer. The computer I use is actually in Cheyenne, Wyoming. It's a supercomputer that we run climate models on. And I use those climate model projections to get a glimpse of what the future might look like if we reduce carbon emissions and if we don't reduce carbon emissions.
Cool. And we just watched your TED Talk, which was awesome. If anyone who's just signing in missed it, you should absolutely go back and check it out later. It was really powerful. And I think that one thing that came up in that TED Talk was that you are a new mother. And I think it's worth wishing you.
Thank you very much. Yeah, you might not have been able to tell. I've had a baby since that talk was given.
That's awesome. You are very invested in the future of snow. And So we've had a bunch of questions come in via Instagram over the last week or so, and do you mind if we just kind of jump into asking you some questions that have come up from the community? Yep. Sweet. So I think the place we'd like to start is if you could give us a quick overview of this kind of climate 101, and how do we know it's warming, and how do we know it's us?
So we have known that CO2 traps heat and that it affects our climate roughly since about 1856. Eunice Foote was one of the first researchers to propose a link between these two important parts of Earth's climate, carbon dioxide and temperature. Since then, the community and the science world has grown on this topic immensely. We've done a lot of work in terms of figuring out, one, that it's warming, not just from instrumental records, so meaning thermometers or ship's logs, but also looking longer and further back in time using stuff like ice cores and tree rings. We also use marine sediment cores going back millions of years. And what we can tell is that right now, carbon dioxide is the highest it's been for the past about 3 million years. And caveat, one thing we know about 3 million years ago in the climate is that it was a lot warmer back then. And especially up at the poles, for example, they didn't exactly have tundra or low-lying vegetation and snow. It was actually more like temperate forest, so forest like in what we have in New Hampshire today. So it's a big change in the climate. One of the things that we know also is that the change that's happening now is happening very rapidly. And it's at a much faster pace than Earth's climate has typically changed in the past. What typically happened over 3,000 of years or so is now happening over the course of 150 years and decades even, much shorter timescales. We know that it's us because we can see the signature in carbon dioxide. So carbon dioxide that's from the burning of fossil fuels has a very unique chemical signature to it. And this means that when we sample air that's been collecting in Earth's atmosphere, we can actually see that change very easily. We can also tell that it's us that's causing the warming because we can investigate other factors like natural factors that also affect Earth's climate but cannot explain the warming that we're seeing today. So for example, I saw in one of the questions that was scrolling by on the side there, something about Earth's axis. And Earth's axis, it does change a little bit. Actually, it's got a globe right there. I could have shown you that, but it changes just a little bit. And that can affect how if Earth is in an ice age versus not an ice age. But again, that happens over thousands of years. And the warming that we're seeing today is actually happening over a much shorter time scale. So it's not Earth's axis. We also know it's not the sun. We know it's not volcanoes. What we do know is that the warming signature we see today can right now only be attributed to something like the burning of fossil fuels.
Cool. I think that answers Sarah's question really well, which is what response can she use to demonstrate to people that climate change is real? And
yeah.
I think that
I'll be posting some stuff on my Twitter account. I'm at Liz Burakowski, and I will be posting some resources for folks if they want to follow up on them, and I'll be sending them along to POW as well. And there's some great graphics and articles that people can dig into that are meant for consumption of people who are not necessarily scientists, but experts in other realms. Yeah.
So awesome. That's fantastic. Okay, so for those of us who love the mountains, how is climate impacting those environments specifically? And what are the additional impacts of shifting seasons?
So when we look at our mountain environments, they're very sensitive to changes in temperature and precipitation, as with many regions of the world. And when we're looking at our mountain areas, we're seeing in winter and in spring these changes in the length of the snow season. When snow is melting in the spring, we're seeing shifts in how much precipitation we're getting. So some regions like the Western US are much more susceptible to snow drought. Snow drought can occur if you have lower than average precipitation, so less snow falling altogether, or if you're having a hard time accumulating snow on the ground. So that would mean that either it's getting melted by a mid-winter thaw, or you're getting a rain on snow event, or temperatures are simply too warm and you're not getting snow to begin with. It's just falling as rain. All of these factors can affect how much snow stays on the ground, and that can be used subsequently in the growing season, for example. So it's not just winter. When we think about the Western US, this is important for agriculture. This is important for forest fires. It's also important for hydropower and drinking water supplies. In the Eastern United States, our forest health is very reliant on how much snow we get. And this can be a really important factor, especially temperature, in terms of invasive insects that attack our forests. Or worse, the ones that I hate the most in the Northeast, ticks. If we have a really short snow season and a really warm winter, that just means the tick season is a much longer one.
Yeah. I mean, those are all really important factors that are really affecting us. And I think it's bringing up ticks and things like that. I mean, it means it's affecting way more than just the climbers or the skiers. It's affecting anybody who wants to go outside. And
oh, well, yeah, I mean, especially for the work that I do, I'm looking mostly at what are the economic impacts, especially for a state like New Hampshire, where we have a large portion of our money coming in the winter is coming from the ski industry. When you think about warmer winters in the future, this is definitely a big concern.
So I think that I'd love to jump into one of the questions that came in through the chat here, which is from Chloe, who's asking for the difference between climate and weather. And could you give us kind of a little explanation of what the difference is there? Because I think that's an important
Absolutely. So I actually teach an introduction to climate course at the University of New Hampshire. And on my first day of lecture, the way I like to introduce it is actually how Mark Twain describes it. Climate is what you expect and weather is what you get. Does that make sense? When you expect winter to be cold and snowy, that's climate. When you have these warmer than average days, when you have these winter heat waves, that can be weather. Likewise, a snowstorm can be weather. And this is kind of the danger in terms of people relying on weather and equating it with climate. When you have a super snowy day, that doesn't mean climate change is canceled, unfortunately. It just means that you have a weather event that's leading to an atmospheric phenomenon in that specific place at that specific time when you have snow. So climate is the long-term average of weather, is the more scientific definition. Climate change is when you see a shift in that's sustained over time. So having one snowy year, which would be like 1 year average of weather, that doesn't mean that you've had a colder than average year and now climate change is canceled. It needs to be sustained over time. And that's exactly what we're seeing in our climate records. That's a great question.
Awesome. I'm just going to respond to one chat from JD, who was wondering about collaboration between outdoor companies in the outdoor industry and POW. And JB, I'm going to recommend that you get in touch with the Protect Our Winters team via the website protectourwinters.org to chat with them about ways that you and other folks you know in the industry can collaborate, because there are a lot of cool opportunities there. Now, okay, so Liz, we were talking about basically like climate versus weather and time, like understanding time scales and data sets. And I think it would be a really interesting time to talk about how we can compare the pandemic that's going on right now and our like methodology of flattening the curve to reducing greenhouse gas emissions, and how those things relate, and what we can learn from what's going on right now and apply towards.
Sure.
Towards
I mean,
climate.
I think you can draw some parallels here. I mean, this is certainly a much different sort of problem in terms of we're not trying to reduce spread of an illness, but we are trying to reduce emissions. Anytime we're emitting carbon into the atmosphere, it is building up in the atmosphere. And over time, how much we emit today is going to dictate how much warming we're going to see in the future. So the more we can reduce emissions today, the more of winter we can preserve for our children and future generations. When I think about reversing the trends, that's a whole different problem. We would really need to not just reduce emissions, we would need to start pulling carbon out of the atmosphere. And that is a much bigger ask. At this point in time, we do not have large-scale technology that can pull greenhouse gases out of the atmosphere and put them back into long-term storage. And when I say long-term storage, I mean like millions of years long-term storage. That's essentially where we got it in the first place. That's the origin of fossil fuels. It was carbon that was trapped in the underground millions of years ago. And to reverse that sort of process is going to take a lot of engineering and a lot of time.
Do you, at the risk of putting words in your mouth, I'll kind of ask you sort of leading question, but you know, I think that the way that we deal with the current pandemic is by paying attention to and acting on the advice of experts and scientists who have been looking at large data sets and understand, based on history and the scientific method, how we should be dealing with like COVID-19. And do you think the same is true?
I think this is absolutely true. And I think there's been far too little listening to experts when it comes to the climate problem. At this point in time, it is essential that we listen to experts, just as we've seen with the pandemic. At this point, we can't just trust people who have vested interests or financial interest in the problem. We need people who are policy experts, who are scientific experts, engineering. I mean, there's a whole community of experts that need to get together to solve this problem. It's not just going to be one community.
Cool. And I think that kind of leans into something that was asked by Jake on the chat here, which is how can climate scientists better communicate? And I would, once again, Jake, I'd point you towards protectourwinters.org. One of the things that we're really working on is this type of conversation that we're having right now, connecting the outdoor community, just climbing geeks and skiing geeks like me, with folks like Liz. I guess Liz, you're also a skiing geek, but a climate scientist, and really working together to spread this messaging, spread this understanding, and move us towards solutions. And as we think about solutions, I'd love to kind of wrap us up with, what can we do? Liz?
Yeah, so I mean, one of the things that I like to repeat a lot is Katherine Hayhoe. She's an amazing scientist from Texas Tech University, and her TED Talk was essentially about the best thing you can do about climate change is to talk about climate change. We know there exists a large partisan divide in terms of who believes in climate change and who doesn't believe in climate change. And to me, talking about it and finding connections to people is one of the biggest barriers that one can overcome when it comes to talking solutions. You first need to talk with folks, see what their concerns are, and then move forward with solutions that meet both of your needs. And at the same time, we also just need to work on an individual level. I'm working to reduce my carbon footprint. One thing the pandemic has taught me is that, I don't need to travel that much. I can do a lot of the work I need to do right here at home. I've also learned that, there's a lot of programs out there that we can use and that we should support to reduce our carbon footprint, say, in our homes. So we had done a whole bunch of new insulation in our house. Some of these are bigger asks. Some of them are smaller. I mean, if you can take a bus instead of driving, you should be able to do that. But the biggest thing also that I think one should do is just vote. You have to vote. And when it comes to voting, you need to let your candidates and the people who are already in office know that you support policies that address climate change and that it's important to you. So I think that's the number one thing you can do is just vote. Yeah.
That was exceptionally well said. And I think that we're going to kind of move towards wrapping up here. Liz, I could sit here and ask you questions for another hour very, very easily, and I think I actually have done that in the past, and I'll do it again. But I just want to let everybody know that that this is part of a series that we're doing with Protect Our Winters, and the next event is going to be on, I think, Saturday night at 6 p.m. Mountain Time. We're going to screen a film with Josh Jefferson. And if you want details on that and sign up for that, go over to the Protect Our Winters Instagram or Facebook pages, and you can get all the sign up details there. And then we're also we're going to put up a slide here in just a second that has a texting code where you can send in Science Talk to 65351, and they'll enter you in a raffle to win this T-shirt, and I bet they'll send you that sticker with it as well. And Liz, is there anything that I've really missed in terms of things, like last things that are kind of bubbling up for you that you want to bring up before we sign off?
No, I'm really happy that everyone took some time out of their day to watch this. And there's so much support that Protect Our Winters is pushing towards climate action. So keep up the great work, pal.
Hey, I agree, and seeing so many people here right now on a Wednesday lunch is really exciting, and it's a sign that we're using this time that we have stuck at home to try to make the world a better place and the kind of world that we want to live in. So that's something that we're really excited about. So Liz, thank you so much for being with us here today. Anybody who wants to revisit the TED Talk or this conversation, I think this is all going to be available online afterwards, and feel free to reach out to us individually, and make sure and follow Protect Our Winters.
Bye, everyone.